Good morning, students. Today we are going to discuss about the third lesson in the first unit. Last class we are discussing about the fundamentals of electricity, DC fundamentals. Now we are going to discuss about the AC fundamentals. What are the objectives of this topic? In this topic, we are going to discuss about terms pertaining to alternating quantities. Alternating quantities which changes the phase or which changes the positive side and negative side are called as the alternative quantities. E.M.F equation of AC voltage. How we can write the electromotive force equation for the alternating current. Whenever we want to represent in the mathematical form, anything we can represent in the equation form. So the AC quantity, alternating quantity is represented by the mathematical equation, that is the E.M.F equation. Next, we are going to discuss about the different alternating quantities: instantaneous value, maximum value, frequency, time period, average value, RMS value, form factor, peak factor, so on. And also, we are going to discuss and know about the phase of an alternating current, whether the phase is changing or uniform. We are going to discuss in this topic. Phase difference between the two alternating quantities, how much they are deviating from first quantity to the second quantity, and representing the phase and phase difference in the circuit. Before going to our topic, first you should know. So, what are the things we are discussed? Do you know how bulb is glowing? Whenever we switch on the bulb switch, bulb is glowing. How you can get that glowing? You should understand and you should think about that. Do you know how electricity is produced? Electricity, where it is producing? Do you know how electricity is transmitted? How the electricity is transmitted? All these should be you should know so that you can get an idea how the electricity is producing, how that produced electricity is transmitted, that transmitted electricity how we are utilizing for our uses, home appliances, industrial uses, like that, how we are using. So now we are going to discuss about the AC fundamentals. So from the AC fundamental, what is the alternating current? When the current varies in magnitude and direction periodically, it is called an alternating current. You know that if periodically changes, that is called as the alternating current. The periodically is called as the period of that alternating current. The magnitude and direction also vary, then only that waveform is called as a alternating waveform. If it is a current, that is called as a alternating current. If it is a voltage, that is called as a voltage. Cycle, the definition is cycle. What is the cycle? One complete set of all positive and negative values of an alternating quantity, voltage or current, is known as a cycle. One complete cycle represents the period of the alternating quantity. When the cycle is completed, if you consider all positive and all negative set, that is called as a cycle. Either voltage or current, both are there. You can also represent like this. A cycle can also define in terms of angular measure. One cycle equal to 360 electrical hour to radians. Another one is there angular velocity. What is the angular velocity? It represents the how speedily the waveform is rotating angularly. It is an angle turn by one cycle during the time period. Unit is radians per second. That is it is an angle turn by one cycle. So whenever the cycle is going, what is the angle? In what angle that is turning, that is called as a angular velocity. Another heading is waveform. What is a waveform? The shape of the curve drawn between instantaneous voltage or current on y-axis and time on x-axis is known as waveform. We can say that waveform is nothing but a curve. That curve drawn between the instantaneous voltage or current with respect to the time. Time is on the x-axis and the magnitude on the y-axis. The examples of waveforms representing alternating current. You can see different waveforms are there. The first waveform is sine wave. Generally, the AC or the alternating quantities are represented in the form of AC sine wave only, sinusoidal waves. The second one is a square wave. You can see here we having the magnitude change, phase change, but that is in the form of square. The next one is the ramp. You can see ramp. Here also we having the positive quantity and negative quantity. That's why it is called as a alternating quantity. Sawtooth waveform also is there. It is like as a ramp, and the triangular waveform. It also having the positive quantities and the negative quantities. These are some of the examples of alternating currents. How we can produce these AC voltages? We can see production of AC voltage, where we produce the alternating currents. These AC voltages are produced at the power plant. In the power plant, we are producing this AC energy. That energy is transmitted to required places. Requires what it requires? Requires the knowledge of Faraday's first law of a electromagnetic induction principle. If you know the Faraday's first law, you can get the idea of how we are generating the electricity. Whenever a conductor cuts the magnetic field, an EMF is induced in it. The Faraday law says that if a conductor cut the magnetic field, magnetic field is the magnetic field. Production of AC voltage. We are discussing this one. So whenever a conductor cuts the magnetic field, an EMF is induced. When a conductor is rotated in the magnetic field, an alternating EMF is generated in the conductor. The EMF thus generated will depend upon the strength of the magnetic field, the number of turns in the conductor, the speed at which the conductor rotates in the magnetic field. How we can derive the E.M.F equation? You can see it shows the figure shows the generation of the E.M.F. How it is generating. Axis x-axis is there, and the magnetic field, the uniform magnetic field is there. In that we having the conductor rotating. Whenever conductor fall in a magnetic field, EMF is generated in that magnetic field. Direction of flux you can see there. Consider the coil which is rotating in the magnetic field. Its axis of rotation is perpendicular to the magnetic field. Take the initial position of the coil along the x axis. Let theta, that is the angle between these, the omega t, be the angular rotation made by the coil, where omega is the angular velocity in radians per second. The flux normal to the plane of the coil at this position. Now you see, according to Faraday's second law of electromagnetic induction, E equals to, that is minus dn pi by dt minus n d pi. The pi is, you can write as the pi m cos omega t. That is the B equal to omega n pi m sin theta. So that way theta is 90 degrees, has the maximum value, and Em is omega n pi m 2 pi fn bma. You can see that where f is the frequency, n is the speed in rpms, rotation per minute, bm is the maximum flux density, a is the area of the coil in a meter square. Hence, the equation is E equal to Em sin theta. So, like this, the alternating wave like this, we having the C. In this, we have the amplitude. The total cycle is 360. 180 is the half cycle, and remaining is the positive cycle. So, the alternating current is equal to Em sin theta. So what we need to have, we have the two values, average value. The average value of an alternating quantity is the steady quantity following through the circuit, which transfers same amount of charge as that of the alternating quantity. So every alternating quantity have the average value. What average value it is producing? It is the static quantity flowing through the circuit which transfers the same amount of the charge as that of the alternating quantity. The another one is the root mean square value. The root mean square value is called as the effective value. We can also call it as the effective value. The RMS value of an alternating quantity is the steady quantity flowing through the circuit produces the same heating effect as that of the alternating quantity. The thing is, how much heating effect is producing, that is indicated by the RMS value. These two values can be measured by using the two methods, that is the mid-ordinary method and analytical method. These two methods can be used. We need to know how we can calculate the average value and how we can calculate the RMS value. We having the two method, mid-ordinate method and analytical method. First, you can see the mid-ordinate method for average value. In this, what we are doing is, whatever the alternating quantity is there, that is divided the time base t into an equal number of times. We divide the total quantity into the equal number of times, and that quantity will be measured by using the each of time duration is t by n seconds. So we can say like this, what we are doing is, let the magnitude of instantaneous currents be I1, I2, I3, so on. the regular intervals of time. The average value we can simply say is that alternating the current is equals to number of instantaneous values by the number, that is gives the average value, that gives the average value. For calculating the RMS value, here also same, we can take the RMS value, divide the time base t into n equal intervals of time. Each of the time duration is t by n seconds. So how we can measure like this, you can see. Let the magnitude of instantaneous currents I1, I2, I3, so on. So what we needed is, for the root mean square value, we need to get the square of that particular quantity, 0.24 I1 square RT. Like that we need to calculate the values. After that we add those them. Then we can see how we are adding H equal 0.24 RT I1 square I2 square. So not needed to the derivation. So how we are getting, we need to get the value. So this is the method. IRMS equals to under root of I1 square plus I2 square plus IN square by n. So this is called as a mid ordinary method. So the total time base is divided into equal number of quantities, and by that quantities we can calculate the RMS value. The problem, some examples you can see. The problem is given: calculate the RMS and average value of a periodic voltage having the following values for equal time intervals, changing suddenly from one value to the next value. We can give an here 0, 5, 20, 50, 60, 50, 20, 10, 5, 0, minus 5, minus 10 volts, etc. So what we need to get? We need to have the RMS value and average value. Already we having the formula for equal intervals. The first one, you try to calculate average value. Average value of the cycle, you can see the total number of cycles for number of cycles is given. So that is called as a average value. The value is 23 volts. The total average value is 23 volts. That the negative minus sign should not be taken. That is also taken as a positive value. Next one, RMS value. You can see RMS value, we now have the formula, the square of the instantaneous values, whatever the given the value, you substitute there. The value we are getting is 31 volts. RMS value is a 31 volts. So we need to solve like this. We having the mid ordinary method is there, analytical methods are there, so we not needed those things. So these two are is enough to understand how we are going to calculate. The first we need to define or to know the various quantities or various definition regarding the alternating quantity. Those definitions are, you can see, the first one is the instantaneous value. You can see the what is the instantaneous value. The magnitude of an alternating quantity at any instant is known as the instantaneous value of the alternating quantity. If you wanted to know the value at particular time, that should be is called as the instant value. At any instant we need to get the value, exact value, by using a equation. So that equation is nothing but a E.M.F equation. So instantaneous value, the advantage of instantaneous value means if you substitute the time, a particular time, you can get that particular time what value or what magnitude and what direction of the waveform we have, that is given by the instantaneous value. The another important quantity is the maximum value. Maximum value, or you can also call it as the amplitude. What is the maximum value? In any waveform, the maximum value is the quantity which attains the maximum within the entire cycle. Within entire cycle, how it is reaching the maximum value that is given by the maximum value of particular waveform. The maximum value of a positive or negative of an alternating quantity is called the amplitude or peak value or maximum value. Generally, alternating quantities are represented as a amplitude or peak value VP value. We can recognize or knows the values of the AC quantity. You can see in the waveform the maximum value how in the positive cycle or negative cycle the maximum peak it attains that attained value is called as the maximum value. Next, another important one is the frequency. You already know the frequency. What is the frequency? Number of cycles per second. What it gives? The frequency gives the how speedily the alternating waveform is changing. That is given by the frequency. The number of cycles completed by an alternating quantity in 1 second is called the frequency. Within a 1 second, how many cycles it is completed, that given by the frequency of the waveform. The frequency units are hertz, cycles per second or hertz. Frequency also important of the alternating quantity. Another one is the time period. Time period is nothing but for one cycle how much time it requires. That is called as the time period. Time taken by an alternating quantity to complete one cycle is called the time period. The time period indicates that how much time we need to complete a one cycle of particular alternating quantity. It is indicated in T. The units is seconds. Units are seconds. The another one is already we discussed average value. So average value, what it gives the average value. Already we discussed the mathematical representation for the a alternating quantity. If it is a electrical quantity, so what is the meaning of average value? It is defined as the steady current which when flowing through a given circuit for given time produces the same amount of charge as produced by an alternating quantity or alternating current when flowing through the same circuit for the same time. That is called as the average value. Why we need to calculate the average value of the alternating current means the alternating quantity is always changes with respect to the time. The changing quantity value we does not find. To find that, what we are doing is we comparing this alternating quantity with the DC quantity. The average value says that this the particular amount of the DC value is equal when the AC current will produce the same amount of charge as this DC current produces. That alternating current average value is nothing but this DC average value. The another one is root mean square value. That is nothing but a RMS value. This is also very very important. So the what is the meaning is we don't know. We don't have any method to find the alternating value. So what we are doing is that value is measured in terms of the DC value. How it is the definition you can see. It is defined as the steady current which when flowing through a given circuit for a given time produces the same amount of heat as produced by an alternating current when flowing through the same circuit for the same time. It is also called as an effective or virtual value. Effective value or virtual value of the alternating quantity is given by the root mean square value. What it indicates that how much the alternating quantity producing heat is equal to the that much of heat produced by the steady current. That steady current is nothing but the RMS value of this alternating quantity. The next we are going to discuss another important parameter, form factor. What is the form factor? The form factor gives the ratio of the RMS value to the average value of an alternate quantity is called as the form factor. What amount of the average charge is produced and what amount of heat is produced is given by these two quantity. The ratio between these two given by the form factor. The another important parameter is the peak factor. The peak factor, it is the ratio of maximum value to the RMS value of an alternating quantity is called as the peak factor. The meaning is how peak the alternate current is moving and how average value we are getting. That is called as a peak factor. Like this we are getting the different parameters. Now we try to calculate these values. So what we are discussed until now, we are discussing about the different parameters involving with the AC quantity. Instantaneous value, we are finding the instantaneous value, a time period and the frequency. We try to find the frequency and maximum value or peak value, average value and RMS value and the form factor and the peak factor. Like this, these 7 or 8 parameter we can find from the waveform. It is important to know the total calculation of the waveform. The first problem you can see, the maximum value of an alternating voltage and current are 400 volts and 20 amps respectively in a circuit connected to 50 Hz supply, and these quantities are sinusoidal. The instantaneous values of the voltage and the current are 283 and 10 amps respectively at t is equal to 0, both increasing positively. Write the expression for the voltage and the current at a time t. So I given all the values. From that we need to find the instantaneous waveform. The solution, you can see what data given. He given the voltage 283 volts, the maximum voltage 400 volts, the maximum current 20 amps. The general form of sinusoidal voltage equation is V equal to V max sin omega t plus pi. From this we can say that V given 283 and V max given 400 sin omega. The theta value given 0 and pi. The sin pi equals to 283 by 400. That is the pi is equal 45 degrees. Pi by 4 radians. You can write there, hence V equals to 400 sin 100 pi t plus 100 pi t plus pi by 4. Omega equals to 100 pi t plus 5 by 4 volts. Similarly, the current equation I equals to I maximum sin omega t plus pi. At t equal to 0, 10 equal to 20 sine omega plus phi. Sine pi equal to 10 by 20. Therefore, the pi equals to 30 or pi by 6 radians. The current equation I equals to 20 sine 100 pi t plus pi by 6 amps. Same way, we also calculate the second problem. An alternating current of frequency 60 Hz has a maximum value of 120 amps. Write down the equation for its instantaneous value. Opening time from the instant the current is 0 and is becoming positive. Find the instantaneous value after 1 by 360 second. The time taken to reach 96 amps for the first time. This is somewhat difficult but easy. What the given values? You can see the given values are frequency 60 Hz, maximum value 120 amps, I equals to 120 sine 2 pi ft. That is nothing but 120 sine 2 pi f is a 60 and t. But t also is given 1 by 360 second. I equal to 120 sine 120 into 180 into 1 by 360. The total value is 120 sine 60. You can know that sine 60, you know the value sine 60, and the total value is 103.9 amps. You can see very simple. The next B given that what is given and what we need to find is here. A given data is frequency given 960 Hz, current is given 96 amps, maximum current is given 120 amps. The equation you know that I equal to Im sine omega t plus phi. From when pi equal to 0, 96, 120 sine omega t. Omega t, from that we can find that t equal to theta by 2 pi f, that is a 53, 360 into 60. That is time, it is 0.0000245 seconds. So like this we need to calculate the values of a equation, instantaneous values, amplitude and the frequency and the time period, form factor, peak factor. Not only these, the alternating quantity having the phase also. The phase gives the angular velocity, that is it is moving from the positive direction to the negative direction. The next topic is phase. What is the phase? Phase is nothing but it is an angular measurement that specifies the position of the alternating quantity relative to a reference. It is an angular measurement that specifies the position of the alternating quantity is called as the phase. So what are the phase? You can see the following sinusoidal waveforms. You can see the equation of the waveform is given v equal to Vm sin theta. The time period is given when theta equals 0, v equals 0. If you substitute there, that equation should represent the alternating quantities. You can represent 0, pi by 2, 2 pi, like that. If you supply there, you can get the wave shape. When the sine wave is shifted left or right with respect to the reference as follows. You can see this is a normal waveform. It is shifted to the left side, shifted to the right side. That shifting is called as a phase shift. You see the representation is there. It goes to the left side, theta plus pi. It goes to the right side, theta minus pi. You can see direction of flux coil. You can see like that. When the above system is rotated in the magnetic field, alpha is the electrical phase angle difference. E.M.F is first induced in coil A and then coil B. The phase difference. Equation of EMF induced in a coil A is equals to VA equal to Vm sin pi. In the coil B is Vm sin pi minus alpha. Alpha is known as the phase difference between the VA and VB. The difference also measured in terms of two terms, that is the leading and lagging. Leading means if the waveform angle is more than the reference angle, that is called as the leading. If it is less than the value, that is called the lagging. Leading and lagging. When a coil B is taken as reference, the equation will be as follows. VB equal to Vm sin t, the reference value. VA equal to Vm sin theta plus alpha. Hence, phase difference is the difference of angles between the two alternating quantities. Between two alternating quantities, how it is, you can see that is shifted to alpha. The wave is shifting. The difference is alpha. By taking VA as a reference, you can see first quantity, second quantity, you can see. For the above waveform, the phase difference between A and B is 45 degrees. You can say 45. The answer is 45. You see simple questions, you can see. You can see how it is. 45 again. The above is leading or lagging. So that is, I think, lagging, because already the reference A is came there. That is called as a lagging, leading. Before it is going, that is called as leading. A is leading, B is lagging, like that we can say. So some questions you can see. What is the maximum value of voltage in the equation of the instantaneous value V equal to 450 sin 340 plus 5 by 4? You can see the maximum value is 450. The another one is, what is the frequency in the equation? You can see where is the frequency. What is the frequency? 3140 pi by 4. The frequency, how we can find the frequency? The 314 is equals to the 2 pi. That is the omega t means 2 pi. So 2 pi means 2 ones are 2, 5 and 7 and pi. The value is 50 hertz. You can see. The another question is, units of the frequency is, you can know the frequency hertz and seconds also, we can say both A and B. You see here. So what we discussed in these topics? In these topics we are going to discuss, we are discussed following the values. You can see Definition of the terms pertaining to alternating quantities. Faraday laws of electromagnetic induction, E.M.F equation of sinusoidal alternating quantity, phase and phase difference, leading lagging of alternating quantities, representation of phase and phase differences. So all these we have discussed. Okay. So some of questions you can see according to Faraday's second law of electromagnetic induction, induced EMF is equal to the rate of change of flux linkages. Induced EMF is equal to the rate of change of current. Induced EMF is not equal to the rate of change of flux linkages. None of the above. That is the answer is induced EMF is equal to the rate of change of flux linkages. Alternating waveform has what it is? Constant magnitude with respect to time? No. Variable magnitude with respect to time? Yes. The B is the answer. And next, cycle is defined as cycle is nothing but if it completes the one set of positive and negative is called as a cycle. Set of all values of positive half cycle, set of all values of no, set of all values of both positive and negative half cycles. That is the C is the correct answer. Next, the questions we need to discuss what we having the questions you can see. So these are the generally asked questions for us. State and explain Faraday's law of electromagnetic induction. Define alternating quantity and give some examples of AC waveform. Define the following for a alternating waveform: angular velocity, cycle, waveform. Derive the E.M.F equation for sinusoidal alternating voltage. And also another terms you can say instantaneous value, maximum value, time period, RMS value. Define phase of an alternating quantity. Define phase difference of an alternating quantity with necessary actions. Okay, so this is about our topic. These in this topic we discussed about the fundamentals of the alternating quantity. So next class we try to discuss about the magnetic field and the representation of electromagnetic field, electromagnetic parameters. So until we discussed about the fundamentals of the electricity. So these alternative quantities plays a very vital role in calculating the values of the current. That values by using this RMS value, average value, and the peak value, instantaneous values, we can find how the alternative quantity is changing, what amount of heat or what amount of effect is produced on our load that is given by these AC fundamental topics. Okay. So next class we try to discuss about these AC fundamentals and some problems on the KVL and KCL. Those are Kirchhoff voltage law and Kirchhoff current law. So by applying voltage law, that is a loop law, and the node law, we can say that KCL at the node voltage, the sum of entering voltage is equal to sum of leaving currents. So sum of all currents at a particular node is equal to 0. Coming to the Kirchhoff voltage law, sum of voltages in a particular loop is equals to 0. So that is called as a Kirchhoff voltage law. So depending or using those two laws, we try to calculate these values. So we also have the simplification of resistors. How we can simplify resistors in series connection, resistors in parallel connection. If we having the n number of resistors are connected in series. How we can write the total amount of the resistance produced by the circuit, and we also discuss about the parallel circuit. The parallel circuit, whenever we connect in the parallel, we need to find the average effect of the parallel circuit. By using the parallel formula, we can calculate the parallel circuit and simplify the circuit. So all these things we are going to discuss in the next class. Thank you for listening this topic. If any doubt, you can ask me. I clarify. Thank you one and all.